Hello everybody and welcome to part 1 of this 3-part tutorial series where I'll be showing you how to build an online multiplayer game in Python. To accomplish this, we'll be using Python, sockets, and then a module known as Pygame, which will represent our UI or our front-end interface. What we'll also be doing is connecting this to a database and then hosting all of these different services so you can see exactly how this would work in a real-world environment where you have clients on different computers connecting to some remote server. This will be a more advanced tutorial series, but this will teach you a significant amount about networking, specifically in Python, and how you can do this in a game setting. Now, what we'll be making specifically is a game that allows two clients to connect to each other, and they'll be kind of racing to answer a bunch of math problems. So two players connect, immediately the game starts, and then they're presented with math problems. They then need to submit the answer to the math problem to the server. It says if they're correct or incorrect, they move on to the next problem. While they're doing this, they can see the live progress of their competitor, and whoever gets to the end the fastest is the winner of that round. Now, this will actually allow concurrent games to be going on, so I'll be showing you how we can set up multi-threading and be able to handle all of these different clients at the exact same time from one individual server. We'll also be connecting this to a database where we'll keep track of a leaderboard of the players that have the most number of wins and losses. Now, before we go any further, I'll quickly mention that my name is Tim. I'm a developer advocate for the channel, and I run the Tech with Tim YouTube channel, which has hundreds of other programming tutorials. If you're interested in that, then check out my channel. And with that said, let's go ahead and get started and code out this server. So let's begin here by just having a look at a quick demo of the application. Then I'll talk a bit more about the architecture and how we're going to set everything up. We'll get into the installation and the different dependencies, and then we'll start writing some code. Now, I'm going to split this tutorial into 3 videos. In the first video, we'll implement the server. In the second video, we'll implement the client side. And in the last video, we'll deploy everything, and I'll show you how we can connect this to a database such that we can keep track of wins, losses, different users, etc. All right, so I have 2 clients here. The important thing to understand is we have one server. We could have multiple servers. In this case, we just have one server, and this hosts our different game. Now, this is going to be a 1v1 game, meaning we can have multiple different users playing at the same time, but all of them are going to need to be paired with someone else. So what I'll do here is go to my game window and just type in a nickname for my first user, which is Tim. Now we need to wait for a player because we need someone else to connect before we can play our game. Okay, so let's go over here. We'll call this guy Yo, and you can see that immediately the game will start. Now, what I'm doing is tracking the number of wins and losses that each of our different players have, just so you can see how you do that and how to connect everything to a database. What we'll do now is we'll have some different math questions, right? So you can see we have 1 + 1 and 1 + 1 over here. And the idea is these two users will be racing against each other to answer all of the questions the fastest. So if I go over to the left side here and I type in 2, you can see that's correct. So it's going to advance me to the next question. And then notice that it shows me over here that the other player, my opponent, is on question 2. This way I can know their progress and see it in real time. Let's go here and do 4. Okay, we advance. Go here and do 2. We advance. And let's go over here and win by typing in 6. When we do that, it says Tim won the game because that was the final question. Now, of course, we can make more complicated questions. We can have more questions. You can really do whatever you want here. But the idea is I'm showing you how we connect 2 players in real time with each other. The server will support any number of concurrent games that we'd like. We're keeping track of the wins and the losses. And then you can see how we can handle synchronization and how we can see real-time data across multiple different clients. The whole point of these Pygame windows is just to give us some kind of user interface. We could do this in our terminal, but I wanted to show you how we kind of connect a UI to a backend server and send some different requests using Python sockets. All right, so let's get into the architecture here. I've just opened up a small snippet of the code that we're going to be writing. Obviously, I've already written this, but we're going to write it from scratch in this video. Now, you can see that what I've done is I've defined 2 kind of inner classes here, one for request and one for response. Now, the response is all of the messages that will be sent from the server to the client, and the request is all of the messages that will be sent from the client to the server. Now, to break down the architecture, we just have one server. The server is responsible for handling pretty much all of the game logic and for kind of pairing our different users together. It's the single source of truth, and that's where all of the messages get handled, where we connect to the database, where we do kind of all of the heavy lifting stuff. The clients are really just sitting there and receiving different messages from the server and responding to it. They're also sending messages back to the server to indicate that they've maybe answered a question or they're leaving the game or whatever might be happening, okay? So you can see here that the server will send these messages to the client. The first is nickname. This means we are requesting a nickname from the client that's connected to our server. Next, we have questions. This means that we're sending all of the different questions, so those math questions, to the client so they can now answer it. We then have start. This means we're actually starting the game process. We have opponent. That's going to send information about who the player's opponent is. Opponent advanced. That means the opponent actually went one question ahead, right? So they've advanced because they got a question correct. Answer valid, that means that they got the answer correct that they submitted. Answer invalid, well, it's incorrect. Winner means someone won the game, so we're going to submit who won that game. And then opponent left means, well, your opponent left the game, so we need to disconnect you from the server. So you can kind of understand here how we have what I'm calling a protocol, which is really just the different messages that we're sending to and from the server, which kind of define the game logic and the communication between our different machines. Next, we have request. So this means we're submitting an answer from the client to the server. Nickname, we're sending our nickname over, and we're leaving if we send this leave request, okay? Pretty straightforward. All we need to do is figure out a way how we can use all of these different kind of methods, right? So sending, receiving, etc., on both the client and the server to set up this game logic and kind of facilitate the communication between different clients. I know this might be getting a little confusing already, but this is the basic architecture, okay? You have your server, you have your two clients. One client connects to the server, they wait for someone else to connect so they can play against them, they get put into a room, and then they start playing the game where they're submitting answers to the different questions. All of the questions are generated from the server, so no client has an advantage until the game begins. So once the game starts, the clients get sent the list of questions, they then answer them as quickly as they can, and whoever answers all of the questions first is the winner of the game. All right, what I'm going to do now is just open up a new folder. We're going to start writing some code from scratch, installing our dependencies, and working on this server. All right, so I've just opened a new Visual Studio Code window here, and I've opened a new folder in VS Code. What we'll do to start is just create a new subdirectory here called server, and inside of here, we're going to make this a Python package by creating an __init __.py file. Okay, you don't have to worry too much about that, but this is just going to make it easier for us to import some different modules, so just add this init file. From here, we'll create a few files that we need. We're going to have a room.py file. We are going to have a protocols.py file, and we are going to have a db.py file, and lastly, a main.py file. Okay, so these are the 4 files we need. For now, we'll really just be working in main, protocols, and room, and then db, well, that'll be our database that we'll implement later on. Now, just to save us a bit of time, what I'm going to do is go to my protocols file and just copy in the protocols that we just looked at, okay? Now, if you want this code, if you want to copy it in, or if you want to pause and write it out, it's up to you, but all of the code will be available from the link in the description. I'll have it up on GitHub, completely open source, in case for some reason something's going wrong and you need to copy that, or in this instance, you just want to copy things like the protocols class, you don't want to write it out from scratch. Anyways, we have our protocols, and we've put them inside of protocols.py. Okay, that is step number 1. Now we're going to close that, and we're going to go over to main.py. Now, inside of main.py, we're going to start setting up a few things related to our sockets. Now, in case I didn't explain this, essentially what we'll be doing is using sockets. Now, sockets are a method of real-time communication that allow us to send messages back and forth between different kind of devices, right? So we have a server and we have a client. We connect those together, and then we can send messages from the client to the server or the server to the client, and the server can facilitate which clients it wants to send different messages to. So in our case, the server will act as kind of the manager of different messages per se, and it will allow us to send different messages to clients that are in the same room or are in the same game. So we need to import a few things here inside of main.py. We're going to import socket, threading. We're also going to import JSON, and we're going to say from protocols, import protocols like that. And then we are going to import time, and shortly we'll import a few other things as well, but for now that's fine. Okay, now when we're using protocols here, we're importing this protocols class, which will give us access to these different messages, okay? Great. Now that we are here, we're going to set up a server class. So we're going to say class server like this, and we're going to define an initialization. So we're going to say define init, and we're going to take in a self. We're going to take in a host, which is equal to 127.0.0.1, and then a port, which in this case is going to be equal to 5 5s, okay? Now we're doing this because we can change the host and the port if we want to. In our case, we're going to be testing everything on localhost, and then eventually we'll go into a deployment environment where we'll actually see how we host this on a real live server. Okay, so we're going to say self.host is equal to host, and self.port is equal to port, and then we're going to initialize our socket. So we're going to say self.server is equal to socket.socket, and to create a new socket, we need to specify the socket type. So we're going to say socket.af_inet. Don't worry too much about exactly what that is, but you can see here it's the address family, and then the next is going to be the socket kind. So we're going to say socket.sock, in all capitals, _stream, like that. Again, don't need to worry too much about that. This is kind of just the default socket we're always going to use. Okay, next we're going to say self.server.bind, and we're going to bind this socket to a specific address and port. So we're going to say self.host and self.port. And all this means is that we're now using this socket on this host and on this port. So that's where we're listening for different connections, okay? So some client will connect to our server using the host and the port that we've specified here, okay? Then we need to say self.server.listen. Now what this will do is allow the socket to actually start listening for different connections. Then we're just going to define a few variables here that we need and then move on to our next methods. All right. So we're going to say self.clientNames is equal to a dictionary, self.opponent is equal to a dictionary, self.rooms is equal to a dictionary, self.waiting_for_pair is equal to none, and that's all we need right now. Now, what these variables will be doing is keeping track of some information related to our different clients and our games. They don't make a ton of sense right now, but we will use them in a minute or two. And for example, waiting for pair is going to actually store the address of a client that's waiting to be paired with someone else so they can actually start a game. Okay. Now, there's quite a few kind of pieces of logic and methods that we need to write here. So I'll start kind of stubbing them out just so that we can see how they're going to communicate with each other. Then we can write the individual messages. So we're going to have a send method. This is going to take in self. It's going to take in an R type, which stands for a request type. It's going to take in some data, and it's going to take in a client. Now we're going to copy this exact same method, and we're going to paste it, and we're going to call this send to opponent. And the idea is that for every single client, we're going to have a dictionary here that stores who their opponent is. This allows us to very easily send messages to someone's opponent because sometimes we want to tell the opponent that, hey, maybe this client left or this client got a question correct. So we need a way to send a message to the client itself as well as to the opponent of that client, which are really the two clients that are in a game together. And when I say client, just think of the actual game instances, okay? So machines that are connecting to our server. All right, next we're going to define a receive method. We're going to say receive like this. This is going to be self. And inside of here, what this will do is receive a new connection. So this will essentially allow a new client to connect to our server. The basic idea is that we're going to have one thread, which is going to be listening for new connections. And then every time we get a new connection, we're going to actually have a new thread that handles the communication with that client directly. That means that all of these different clients can be communicating at the exact same time or in different threads. So we're never waiting for one client to send or receive a message before we can handle another client's communication request. Again, I know it seems a bit confusing. As we continue through here, it will make more and more sense. Okay, so those are a few of the methods we need. Next, we're going to have define handle_connect. Now, what this is going to take in is a message and a client. And sorry, this is actually just going to take a client. My bad there. And what this will do is handle connecting one individual client. So essentially, inside of receive, we're going to be receiving a bunch of different client connection requests. As soon as we get one of those, we're going to pass that off to the handle connect method, which is going to handle actually allowing one of our clients to connect to the server. Next, we're going to have a create room function. This is going to take in self and client. And what this will do is create a new room object, and the room will be storing the two different clients that are communicating with each other or that are playing in a game. Okay, next we're going to have a define wait for room. This is going to take in a self and a client again. And this is what we'll be calling when we're waiting for a room to be available. So we're essentially waiting for someone else to connect so that we can pair our client with them. Next, we're going to have a handle function. This will take in, again, self and client. What we'll do is from receive, we'll call handle. Handle will then use all of the other methods that we have to handle the connection and the kind of requests from one individual client. And we need a few more. We're going to say define disconnect. Okay. What this is going to do is disconnect one client. So sometimes a client will disconnect. If that's the case, we need to handle that. So we have that method. And then lastly, we're going to have a handle underscore receive. And what this will do is take in a message and a client. And this will handle receiving a message from a client. Okay. So let's go into receive here. And you can start kind of seeing how we'll hook up these different methods together. I know we have a lot of them, but I just figured we'd stub them first before we move too far. Okay. So we're going to say while true, because we want this to happen, infinitely. We're going to say client, comma address is equal to self.server.accept. Now what this means is that we're essentially going to wait here for a new connection. So this is a blocking line of code. What that means is that we're not going to move past this line of code until we receive a connection. So we're essentially sitting, waiting forever until we get a connection. As soon as we get one, we'll handle that connection and then kind of move on and set up a new thread for that connection to be kind of handled, okay? Now, what we'll do just for a bit of logging is we'll print an F string and we'll say connected with, put in a set of parentheses here, string address like that, just so that we can see that we got a new connection. Then we're going to set up a new thread. So we're going to say thread is equal to threading dot thread. The target for this thread is going to be equal to self dot handle. And then the arguments that we want to pass to that function are going to be client. And we just need to make sure we put a comma here so that this is treated as a tuple. Seems a bit weird, but just make sure you have the comma here. If you don't have that, you're going to get an error, okay? So we have thread is equal to threading dot thread. And then we say thread dot start. Okay. So why do we need this? Well, the reason we need this is we want to have a separate thread that is non-blocking or not relying on this thread here, where we're going to handle the individual message requests for a client. So the idea is this is blocking code. So as soon as we get past this, meaning we've accepted a connection, we set up a new thread for that connection. So all of that logic can be handled and not blocked by the existing thread. If we didn't set up another thread here, what would happen is we'd kind of accept a connection, we'd handle that connection one time, and then we'd be stuck here waiting for another connection, waiting for someone else to join the server. That's not what we want. We want to have a separate thread that can run independently of this thread such that we can accept other connections while simultaneously we handle the communication between all of the current connections that we have. That's why we need the thread. Okay, so the target is handle. So handle is the first kind of method that we're calling here, and this handles the communication between one of our clients. So let's go to handle and see what we need to do. Okay, well, for handle, the first thing we're going to do is we're going to say self.handleConnect because we need to handle connecting right away, and we'll just pass the client here. Then we're going to call self.wait_for_room because we can't kind of move into the main logic that we need for this connection until a room is set up and we have two people that are playing against each other. So hopefully the way I'm writing this is making a bit of sense in terms of the different methods, but we're first going to handle kind of allowing this person to connect. And what's involved in that is getting a username from this client. So the basic flow, if we go back to our protocols here, is as soon as someone connects, we're going to request that they send us a username. Once they send us a username here, then we're going to put them in the queue for a room. So we're going to wait for a room to be available. As soon as a room is available, meaning we have two people ready to be matched against each other, we're going to send the list of questions to both of the clients, and then we're going to send the start command. When we send that, it's going to start the game, and the two clients will start playing against each other. Then we have all of the other kind of messages here that we'll use later on. All right, so let's go into handle connect. So for handle connect, what we need to do is essentially just get a username from our client. So we're going to say while true, and we're going to say self.send, and we're going to send the protocols.response.nickname. Okay, we're going to send no data, and we're going to send this to our client. Now, if we go and just look at send to make sure this is clear, we take in an R type, which is a request type, data, which is the data we want to send with that request, and then the client we want to send this to, right? That's what we're doing with send. So what I'm saying is, okay, we're going to send the message that's requesting the nickname, right? So protocols.response.nickname. So we're requesting the nickname from our client. And then what we're going to do is wait for the client to send us that nickname back. So we're going to say message is equal to JSON.loadS, and this is going to be client.receive. we're going to receive 1024 bits dot decode. And actually, I think that's bytes. Sorry, let's look at this here. It doesn't say what it is. Okay, I'm pretty sure that's bytes though. We're going to decode this using ASCII. Okay. All right, so let's explain what's going on here. What we're going to be doing is sending JSON data to and from the clients and the servers. So every time we want to receive some data from a client, what we write is this client.receive, and then we put the number of bytes that we'd like to receive as a maximum. In this case, 1024 is fine. You might need to increase that if you were sending a lot more data, but this is fine in our instance. So what we're doing is we're essentially waiting for the client to send us data. Whenever you see a line like client.receive, what we're doing is waiting at this point until we get some data. So we'll kind of just be sitting here infinitely until some data is received. Once that's received, what we're going to do is decode that using ASCII. Now, the reason we need to decode this is because recently Python implemented the standard where you always need to be sending encoded data. So from our client, we're going to encode our data. Then we need to decode that data. Once we decode this, what we're going to end up getting is a string that is JSON data. Okay, so it's going to look like JSON, hello, 123, whatever the data is. Then we want to load this into a Python dictionary. So we use json.loads, which then takes a JSON string and returns a Python dictionary of that JSON representation. So now we have the message, and we're going to say our request type is equal to message.get, because now this is a Python dictionary, so we can use .get, and we're going to get the type, and then we're going to say data is equal to message.get, and then the data, okay? So we now have the Python dictionary, so we can get the type from that dictionary and the data. The way that we're going to be sending data is we're always going to have this type field, which is going to be one of our protocols, okay? So nickname, questions, answer, nickname, whatever it ends up being, okay? That's what it'll be. And then data, and data will be associated with, well, whatever the data is that we're sending across, okay? So in the case of nickname, what will happen is the type will be protocols.nickname or whatever it ends up being, right? Don't need to type it all out. And then the data will be the nickname, so something like Tim. Then we can load that in and we can use that. So what we're going to say is if the r_type is equal to protocols.request.nickname. Now notice I'm using request, not response, because this means we are waiting or kind of checking if the user sent us a request that contained that nickname data. So we want to see if they sent us this, right? Sent nickname. Okay, so we're checking for that. If that's the case, then we're going to say self.clientNames at our client is equal to data, which is right here. And really what we can do is we can make this nickname because that's what we know that's going to be. So we can say like this, if the r type is equal to protocols.request.nickname, so if they sent us the kind of correct payload that we're looking for, then we're going to take whatever the data was, which is their nickname, and we're going to associate that with their client. So the client here, again, remember, is passed once we connect. So the client is really a socket object that we can be using to send and receive different data. So we take that socket object and we associate that with their nickname. So we now know this socket is really this person. Then what we do is we do an else statement and we say continue. The reason we need this is because if they didn't send us this type, that means they didn't submit the nickname. So we're just going to continue and wait until they eventually do give us the nickname. All right. So now at this point, if we've made it down here, so that means we did actually get the nickname, we're going to check if we need to make a room or if we are waiting for a room for this specific user. So we're essentially going to say, if not, self.waiting for pair, which means we are the first client that's connected here, or we already had two clients that connected, and now we're kind of the first client that's connected, waiting for some room or waiting for someone else to join. We're going to say self.waiting for pair is equal to client, and then we'll just print out waiting for a room. Okay. Otherwise, we're going to say self.create room, and we're going to create a room with this client, and then we're simply going to break. All right, so let's take a step back here. We're handling the connection, right? This is kind of the first time a client connects. What we do is we ask them to give us their nickname. We then wait for them to send us something. We check if what they sent us was a nickname. If it was, we kind of add that nickname to the dictionary. If it wasn't, we wait until they give us the nickname. Now at this point, we've received the nickname. So we're going to say, if not self.waiting for pair, that means, okay, is no one waiting for a pair? Well, if no one's waiting for a pair, that means everyone's already in a room, everyone's already playing. So now what we need to do is kind of make ourselves wait for someone else to join. So we say self.waiting for pair is equal to client, and we print out we're waiting for a room. If that's not the case, that means someone was currently waiting for a pair. So we're now the second person that's joining that's waiting. So we can group ourselves together and start playing. So that's why we say self.createRoom. And that means we're going to create a new room with ourselves and whoever was waiting for that pairing, because now we have 2 people. Then we break out here because we've handled the connection. So we break out of the while loop. So now we get outside of that and we move on to the next kind of state of communication. So first state is we wait for the nickname. As soon as we've got the nickname, we then need to wait for a room to be created, which is what we're doing right here. Okay, so now that we've handled the connection, we want to wait for a room and we want to create a room. So let's actually do create room first, and then we can kind of write the waiting for room. So we're going to print creating room like that, and then we're going to make a new room. Now we're going to say room is equal to room, and we're going to build a room class, which will kind of store information about the different clients that are playing together. So let's go ahead and do that. We're going to go to room here. And inside a room, we're going to write a class room. Okay, so room, we're going to say define __init. And we're going to take in 2 clients. So client 1 and client 2, which we're going to put in a room together. Then we're going to say self.questions is equal to the following. So actually self.questions, self.answers is equal to self.generate questions like that, which is a method we're going to write. And we're going to say self.indexes is equal to, and this is going to be client 1 and client 2 : 0. Now the idea here is we're going to generate a list of questions and a list of answers that are associated with each of those questions. Then we're going to keep track of what question the current player is on, or each player is on. So client 1 will start at question index 0. Client 2 will start at question index 0, and then we'll increment these indices as the users get these questions correct, okay? So this room is kind of keeping track of where our different clients are in the set of questions that we have. Then we'll just have a self.finished is equal to false. This is just so that we know if this room is done and if someone has reached an index which is equal to the last available index for our questions. Now I'm just going to fix my indexes here, because I spelt that incorrectly, and I know that's still spelled incorrectly, but that's what I did in my original code, so I'm just going to leave that here. And then I'm going to define a function here, which is generate questions. This is going to take in self. And for now, we're just going to return some hard-coded questions in strings, but you could randomly generate these if you want to, okay? So I'm just doing some hard-coded ones. Again, you can kind of randomly select them, and for the answers, we'll do 2, 4, and 6. Perfect. Last thing to write here is just one method we're going to need. So we're going to write verify answer like this. And what this is going to do is take in our client and the attempt that they had. And it's going to see if the answer that they submitted is the correct answer for the current question they're on. So we're going to say if self.finished, then we are going to simply return false, because if the game is finished, well, it's not going to be correct whatever you submitted, because you shouldn't be submitting an answer. Then we're going to say index is equal to self.indexes, and we're going to index our client. And we're going to say the answer is equal to self.answers at whatever the current index is that this client is on. So that's essentially getting the answer associated with the question the user is on. Then we're going to say correct is equal to answer equals attempt. Okay, so we're just comparing what the correct answer is with the user's attempt. And we're going to say if correct, then self.indexes like this at client plus equals 1. And then we will simply return the correct variable here, telling them if they got it correct or not. Okay, so that is our room class. Perfect. Now let's go back to main and let's use this. So if we're going to create our room, what we need to do is make this with our client and then the self.waiting for pair. So whoever was waiting to be grouped into a room, that's who we're putting in a room with this client, right? Next, we're going to say self.opponent of our client is equal to self.waiting for room, or waiting for pair. I keep messing that up. And then we're going to say self.opponent of the self.waiting for pair is equal to the client. The idea is, again, we just want to store who's in a room together, so we know, given any client, who their pairing is, who their match is, right? There's a lot of other ways to do this, but this is the way that I'm setting it up. Okay. Lastly, I'm just going to go up here and I'm going to import room. So I'm going to say from room, import room. So now we don't get an error when we use that here. Okay, great. Next, what we're going to do after this is we're going to say self.rooms of the client is equal to room, and self.rooms of the self.waiting for pair is equal to room. And then we're going to say self.waiting for pair is equal to none, because now we've put that person in a room. Now we're also in between here going to send something to each of our clients. So we're going to say self.send protocols.response.opponent. Now in this case, we're just going to send the opponent's name. So we're going to say self.clientNames, and this is going to be of our client. And we're going to send this to self.waitingForPair. And then we're essentially going to do the reverse thing here. Self.send, not that, protocols.response.opponent. This is going to be self.clientNames of self.waitingForPair. And we're going to send that to our client. Okay, so let me explain what we just did here with the send. The idea is once we've created a room, we essentially need to tell each client who their opponent is, right? So that's what we're sending right here. We're saying, okay, we're going to send the response of opponent, which means, hey, we're giving you the data about your opponent. We want to get the name of your opponent. So we're saying self.clientNames client, and then we're sending that to self.waitingForPair. So we're getting the name of this person's opponent, and then we're doing the exact same thing, and we're sending that to the client that just joined. We're sending the name of their opponent, okay? Then what we're doing down here is we're creating the rooms. So we're saying self.rooms of client is equal to room. Self.rooms of self.waitingForPair is equal to room. So now they each know they're inside of a room. And then we're resetting self.waitingForPair. Okay, I think that's all we need here for create room. Now we need to write the wait for room function. So what we'll do in here is we'll say while true. And now we're going to say room is equal to self.rooms.get. And we're going to get client. And then we're going to say opponent is equal to self.opponent.getClient. And we're going to say if room and opponent. So if we do have a room and we do have an opponent, then we can break out of this while loop. However, as soon as we have a room and we have an opponent, that means that we're ready to start the game. So what we can do is say self.send protocols.response.questions, and then we can send the questions that are associated with our room as the data, and we'll send that to our client. Then we're going to say self.send protocols.response.start. We don't need any data, so we'll just pass none. And again, we'll send that to our client. Now, one thing I'm going to do here is I'm just going to import time. So time is actually already imported, sorry. And I'm going to go here, and I'm just going to say time.sleep1. Now, what this is going to do is just force us to sleep for 1 second. So that means we're going to send the questions, and then 1 second later, we're going to start the game. Now, let me walk through this one more time. I know it's a bit confusing. We'll kind of start from the beginning and see everything that we're doing. All right, so if we go down here, we have our receive. When we have receive, what we're doing is we're waiting for some type of connection. Once we get a connection, we're going to print someone connected, and we're going to start a new thread called handle. Well, this is kind of the function that we're going to be calling, which is going to handle the communication for this client. So if we go to handle, the first thing we do is we handle the connection. So when we go to handle connect, what we're doing is we're sending that we'd like to receive a username. We're then waiting for that username to be received. So that's essentially what we're doing on this line. We are then getting the type and the data of whatever the message is that the client sent to us. We're making sure that they did indeed give us a username. And then we're checking if we need to wait for someone else to connect or if we're ready to immediately go in a game. So 2 situations, we're either waiting for someone else or we can create a room and we can actually start the game between 2 different players. So in the second situation where we can just create a room, what we do is we go to the create room method. Inside here, we make a new room, we set each player's opponent, and we send a request to each player, or we kind of just send a response, saying, hey, you just had an opponent join. Here's who your opponent is. This is their information. We then set the rooms for each player, and we reset self.waitingForPair. Now notice that here, after we handle a connection, so after we've done all this stuff, we're kind of breaking out, right? And now we go into self.waitForRoom. So inside waitForRoom, we're waiting for our room to be available. Now it could be available immediately, or we could be waiting for it if we're in the unfortunate situation where we were kind of the first player to connect and we're waiting for someone else to join. Okay, so here we're getting the room and we're getting the opponent. And then we're essentially checking if we have both of these. If we do have both of these, that means, okay, we're ready to begin the game. So we're going to send a message to the client that says these are the questions that are associated with this game. So it'll send a list of, say, 7 questions, 10 questions, whatever it may be. We then sleep for 1 second. You can make this less, you can make this more, it's up to you. And then we send another request or another response, whatever you want to call it, saying, hey, we're ready to start the game. Now at this point, we've set up all the initial connection stuff. We know the 2 clients that are kind of in the same room with each other. What we now need to do is handle the main logic of the game where we're listening for certain messages from our clients. Really what we're listening for is if they're submitting different answers. So now what happens is the clients will simply send a message to us saying, hey, we have an answer for the current question we're on. The answer is 2, 3, whatever. We then verify that answer. And if it's correct, we advance the client's index, meaning they move on to the next question. If it's invalid, we send them back saying, hey, that was invalid, try again. Hopefully that's making a bit of sense, but that's the basic logic we're going to move into now. Okay, we're going to go now into handle. So we've waited for the room, we've handled the connection, and now we can kind of do the main logic. So we're going to say while true, and we're going to put a try and accept block here. Try accept. Now inside of accept, I'm just going to break out. The reason we need this is because at some point in time, it's possible that the client disconnects for some odd reason. If that's the case, we don't want to raise any exception. We just want to break out of the while loop and kind of exit out of this thread, which is what will end up happening. Anyways, we're going to go into try here, and we're going to say data is equal to client.receive 1024.decode, and we're going to decode this using ASCII. We're going to say if we don't have any data, then we're just going to break out. So for some reason, they sent us an empty message. Otherwise, we're going to say the message is equal to JSON.loadS, and we're loading the data. Remember, we're sending JSON data back and forth, so we're always going to load that into a Python dictionary. Then we're going to say self.handleReceive, and we're going to pass here the message and the client that we got this message from. All right, pretty straightforward. All we're doing here is using the current client, we're waiting for some message to be received by them. As soon as we receive it, we make sure we have some data. We load in that data, and then we pass that to the self.handleReceive method, which will actually handle what we need to do based on the type of message that we receive. Now, if some error happens, we just simply break out. And then what we're going to do down here is we're going to say self.send to opponent. And this is going to be protocols.response. And this is going to be opponent left. The data will simply be none. And we're going to send this to the client. Yeah, that will work fine. The way that this kind of works is send to opponent is going to look for the opponent of this client and just send the message to their opponent. So we're sending to the opponent, hey, your opponent left, meaning this client disconnected. We're then going to say self.disconnect client, and there's some cleanup operations we need to do when a client disconnects. We'll look at that in a minute. Okay, that handles handle, no pun intended. Now we need to go to handle receive. So inside of handle receive, we need to essentially look at what the request type is that we received. So we're going to say r_type is equal to message.get, and we're going to get the type like that. Then we're going to say data is equal to message.get, and we're going to receive the data, and we're going to say that the room that we are currently in is equal to self.rooms at the client. Okay. Now what we need to do is just check for what message this client sent. So really the only type of message we're looking for is if they sent an answer. So we're saying if the r_type is equal to protocols.request.answer. And in fact, what we can do is actually reverse this. And we can say if the r type is not equal to that, then we can simply return. Otherwise, we can handle that type. So what we're going to do is if we receive an answer, we're going to check what that answer actually was and verify if that's correct based on the current question the user is on. So we're going to say correct is equal to room.verify_answer. And we're going to take in our client and our data. Now, if we go back to verify answer here, we can see that what this does is tell us if we got the answer correct based on the current question that we're on. So that's what it's doing. Straightforward. If we go back here, now we need to check if we got it correct or if we didn't get it correct. So we're going to say if not correct, if we didn't get it correct, then self.send, and we're going to send protocols dot response dot answer invalid because this was wrong. We don't need any data associated with that. And then we can send this to our client. Okay, then we're going to return, because if we didn't get it correct, there's nothing more we need to do. We're just going to send them a message and say, hey, that was wrong. Okay, next, we're going to check if they got it correct. So since we're going to pass this, that means they did get it correct at this point. If they got it correct and they won the game. So we now need to essentially handle, okay, did they win the game or not? That's what we're going to be checking right here. So I'm going to say if room.indexes at client is greater than or equal to the length of room.questions, if we spell that correctly, then what that means is that we actually won the game. The reason we know we won the game here is because we've reached an index that is the same or greater than the length of the number of questions. That means that we've answered all of the questions correctly, and we've advanced to the point where we have no questions left. So that's the win state. So what we'll do here is we'll say if not, room.finished. Now, the reason I'm putting this here is because it is possible that two clients can finish at a very similar time. If that's the case, since we're running this in multiple threads, they may both enter this statement at the same time, which is not really what we want. So we're going to make sure the room is not already finished first. If it's not already finished, then that means that we can actually kind of do what we need to do related to the win. So I'm going to say room.finished like that is equal to true. Okay, so if it's not finished, we're just going to declare this is finished. We're also going to update the database at this point, so update DB. We'll look at that in 1 second. Don't worry about that too much. That's going to be in a future video. And then down here, we're going to say self.send to opponent. This is going to be protocols.response.winner. For the winner, what we're going to send is the opponent name. So we're simply going to say self.clientNames, and then this is the client, and we'll send that there. And then we're going to copy this down one more and say self.send like that. Now, essentially what this is doing is just notifying both the client and the client's opponent that someone has won. In this case, the person that won is this client. So we're just taking the name of the client and we're sending that across so that they know, hey, this is the person that won. So that's all we need there. We're then going to put an else statement here, and we're going to say self.send to opponent, and we're going to send to the opponent of the current client, protocols.response.opponent advance. And then we don't need any data here, so we'll just put none. And yeah, that's fine. We can go here and send this to the client. And then we're going to say self.send protocols.response.answer valid, none, and then again, send that to the client. Okay, I know we just did a lot there. We can slow this down and go through it one more time. Essentially what we're doing is getting the request type, getting the data, and then getting the current room just because we're going to use that for this user. We then check if the request type is not equal to protocols.request.answer. That's the only one that we want to be receiving here. So if it's not equal to that, we simply return because there's nothing we need to handle. Now, if it is equal to that, that means the data they submitted is going to be the answer for whatever question they're currently on. So we say, okay, let's check if that answer is correct. If it's not correct, we're just going to tell them, hey, they got it invalid. Now, if it is correct, we need to check if they won the game. They won the game if their index is greater than or equal to the number of questions. Now, if they did win the game, we're quickly going to make sure that no user has already won the game. If that's the case, then we say room.finish equals true, and then we're going to update the database, which indicates who won and who lost. Again, we're not going to do that right now, just putting a comment so we know to do that later. Then what we do down here is we say, okay, we're going to send to the opponent that the current winner is whoever the client is, and then we're going to send to the client itself that, hey, they won the game. So we're indicating, yep, you are the winner. Now, if this is not the case, so if they didn't win, that just means they got a correct answer. So we go here, and we need to tell the opponent that their opponent advanced. I know that's kind of a weird way to say it, but essentially the opponent of this client, we need to let them know that this client advanced so they can see that we're making progress. And then we need to tell the current client that they got the answer correct, which is what we're doing here. That is handling receive. Now we're almost done here. We just need to write send to opponent, and then disconnect. And I think we'll actually be finished with the server. So let's go ahead and write send and send to opponent. All right, so we'll start with send. What we need to do is essentially create a JSON payload, encode that, and then just send that. So the way we do this is we say message is equal to, and we're going to say type is associated with type. And actually, it's going to be r_type, sorry. The reason I'm using r_type and not just type is because type is a built-in keyword in Python, so you're going to get some weird errors if you do that. And then we're going to say data is associated with data right there. Then we just need to turn this into JSON. So we're going to say message is equal to JSON dump s, which means dump into a string. We're going to pass the message, and we're going to encode this using ASCII like that. Now, the reason we need to encode this again is because for some reason you need to encode all of the different strings before you send them across the network. So all we do is just take our JSON object, which is now a string, we encode that string, and then we can send it. So client.send, and then we send the message like that. Perfect. Now, what we're going to do when we send to opponent is actually the exact same thing as this, except we're just going to send this to the client's opponent. So what we'll do in send to opponent is we'll say opponent is equal to self.opponent.get the client. We're going to say if not opponent, then return. Otherwise, we're simply going to say self.send with the r type, the data. This time, though, we're going to send to the opponent. We're not going to send to the client. Hopefully that makes a bit of sense. All we're doing in send to opponent is just kind of choosing or selecting who we're sending the message to by grabbing their opponent. We just want to make sure that we check if they do actually have an opponent first. Otherwise, we'll get an error if we try to send it to them and while they don't exist. There you go. That's all we need for send and send to opponent. Now let's do disconnect. Now, when we disconnect, what we essentially need to do here is clean up all of the data that we currently are storing about this client. So what that means is that we kind of need to tell the other client that their opponent left, which is what we're doing right here. But then we need to remove all of the rooms we've set up. We need to remove the client's name. We need to get rid of a bunch of stuff related to that. So we're going to just start by saying, okay, if this client left, we want to get this client's opponent because we need to clean up them and their opponent because we're going to disconnect their opponent when this client disconnects. Again, I know that seems a bit weird, but the idea is, hey, if you're in the middle of a game and your opponent disconnects, we're going to disconnect you as well, just so that we're kind of shutting down the room, and then we'll allow you to reconnect, sorry, and you can play against someone else. So we're going to say self.opponent.get client. It's possible this opponent doesn't exist. They could already have been cleaned up by some other thread, which is why we need to check this. And I'm going to say if opponent and self.opponent.get opponent, then what we're going to do is delete self.opponent at opponent. Now, what this is doing is it's checking, okay, you are disconnecting this current client, but your opponent, we need to disconnect as well. So we're going to check if your opponent exists, and we're going to see if your opponent is inside of the opponent dictionary. If that's the case, we're going to delete whatever's associated with your opponent in the opponent dictionary, which really means we're deleting the link between the opponent and the client that's disconnecting. That's what we're doing, okay? Next, we're going to say if client is in self.clientNames, then del self.clientNames at client. We're going to say if client is in self.opponent, then del self.opponent at client. We're going to say if client is in self.rooms, then again, del self.rooms client like that. And then we'll say if opponent is in self.rooms, then del self.rooms opponent like that. And I think that's pretty much all we need to do. Lastly, we'll say client.close like so. All right, so I think that's good. Actually, I think the only thing I'm forgetting is this. If opponent is in self.clientNames, then we want to delete self.clientNames at opponent. Okay, so that should clean up everything. There's actually a better way we can do this too. We can say if opponent in self.opponent. And let me just kind of group these together because I realized I did this a bit messy. So we'll kind of write it like that. So now we're handling cleaning up the opponent's dictionary, cleaning up the client names dictionary, and then cleaning up the rooms dictionary. And then we are finally closing the connection. When we close this, this means we're going to shut down the socket. So now we are forcing the client to disconnect from the server. All right, so that's pretty much it. All we need to do now is just write a line here. And actually, we can write this directly inside of our init.py, where we're going to start the server. So let's go back to server here as soon as we kind of import or initialize this server module. Now, there's two ways to do this. First, we can just write inside of main.py here, if underscore underscore name equals underscore underscore main, we can say server is equal to server like that. And then we can say server.receive. And as soon as we call .receive, that's immediately, sorry, going to start our server, which is kind of what we want. Otherwise, we can actually take this exact same code and we can put this in init.py, and then we can just import server. So I believe we can say from dot import server. That should work. Module, actually, no, that's not going to work. We're going to say from main import server. Okay, anyways, from main import server, and then we have this. That means if we run this directly as a module, it will run our server, or alternatively, we can just run this main.py script here, and that will initialize our server. So let's go ahead and do that. Now, we're not really going to be able to test it here because we don't yet have a client, but we can at least see if we're getting any initial errors. So we're going to cd into server, and then go with Python main.py. And you'll see that this kind of spins up the server for us. Nothing's happening right now because we haven't connected to it. But in the next video, when we write our client, we'll connect to the server. We'll see some kind of messages or logging going on saying that the server has started. And then we can kind of see all the stuff that's going on and test it out and make sure it works. All right. With that said, that's going to wrap up part one. I know we haven't really seen any results yet. We have a lot of the core logic done and the difficult part of this tutorial series finished. If you understood this up until this point, that is fantastic. Obviously, it's just going to continue to make more and more sense as we move on to the client. All right, so that was video one. I hope you enjoyed. Now, just to segue into video two here, what we'll be doing is building the client. So we'll actually start connecting different clients to our server. We'll build out that front-end user interface, and we'll start to really see this more in practice. I know this was very theoretical. Just hang tight. In the next two videos, we're really going to dive into actually making all of this work together, and you're going to see how we have all of these different socket and networking operations kind of tie in to one solid game and one solid system. Anyways, I hope you're enjoying the tutorial series. Make sure you check out part 2.